Discord.
Okay, stream is running.
Let's see whether we get some feedback. Yeah, it's there.
Very
Carl
good.
told us. Yep, works.
Very good. Cool. So I just want to give people enough time to join in the last couple of minutes. So I set the starting time to 5:25. So I was a little bit over eager with that. So those were now some tense 5 minutes until it starts, I guess. So. And since we are already set up, I'm going to put on my slides again, share my screen again, because we are live streaming, we are recording, we are seeing my slides, we are seeing myself, and it's 5:30 sharp. Should we wait a little bit, or
yeah,
are we okay with starting really sharp? Like,
let's wait for another 2 or 3 minutes, because I see people are still coming in.
Yeah.
So I guess, yeah, it would be a good thing to wait for another few moments.
That's very good.
Yeah. Somebody's asking on Discord why the chat is deactivated on YouTube. If you are currently listening, we have a Discord channel. I will post the invitation link to the. Oh no, I can't post the invitation link on Discord. Doesn't make sense.
The invitation link is posted on the YouTube page. So if you are on
very
YouTube,
good.
You can join Discord directly. If you are already on Discord, you don't need YouTube.
That's the message that we want to tell you. Yes.
So if you are already on Discord, welcome. Nice having you on Discord. So we had an original setup where we could pop in Discord messages on the live stream on YouTube. But the one person in Linz who knows how to do that is stuck in traffic. So we are now on plan B. I'm terribly sorry for that. We try to make that working next time.
Yeah, people are already saying hello. Ryan, you're also on Discord now.
Oh my. Okay, there's my mouse. Okie dokie. I'm starting at your go, Rainer.
Yeah, I have to answer one question on Discord. Somebody is still looking for the Zoom link. Give me a sec.
I haven't posted the Zoom link again because I don't know why, actually. I was so focused on YouTube. I guess that's why.
All links are on. Good. I think I answered the question. Stefan, what do you think? Should we get started?
Shall we? Okay, we shall. Alrighty. So first of all, welcome everybody to our very first Rust meetup from the Rust Meetup Linz group. We are excited to have you here. It's our very first time. We are still trying to figure some things out. You should see my slides and you should see this rusty metal thing. If you are not from Linz and don't know what this is an art exhibition along the Danube. So the river Danube flows through Linz, and we are a city with a very rich tradition in the steel industry. So there's the big first Alpine Stahlwerk, which I can see from my office window actually, producing steel for ages. And we thought it might be a nice tagline when we start the Rust Meetup Linz that it's time for the steel city to rust, get the pun, and all those metal art exhibitions are also very rusty. And that's why we took those images and put it everywhere on our social media channels. So I think it's a perfect fit. We are really excited to start. And if I say we are 5 organizers from the Rust Meetup group in Linz, the 5 people you can see here. It has been initiated by Rainer and the Coding Club in Linz. be sure. So I just got the Twitter handles from the 3 people that you can see here. And yeah, be sure to follow us, or be sure to check out the Coding Club Linz. They are also organizing the Coder Dojo every Friday, I guess, Rainer?
Yes, we do that. Coder Dojo every Friday.
Even during Corona times, like virtual
Yes.
Coder Dojo. And I want to pass the word to Rainer, because Rainer initiated the whole thing, and he can tell you best about what Rust Linz is all about.
Thank you very much for this quick introduction. Rust Linz, why we founded Rust Linz? We founded it because we saw that more and more people get interested in this technology. And I talked to a lot of people who shared my enthusiasm about this platform. And many told me, I want to take a look at this new language, but it's so hard to find time. And at some point in time, I thought, hey, why don't we start a meetup where you can take a little bit of time, you meet like-minded people, and you talk about topics on Rust and so on. And this is how the idea got spreaded. I asked some friends, you saw them on the previous slides, and they were all passionate about it, and we simply started it. The whole idea is to bring interested people together in this meetup, but we don't only want to make it for Rust professionals. It should really be a room for people who are interested in this technology, even if you are new to this technology, to learn about Rust, to hear about interesting applications and things like that. We also want to mix a little bit international guest speakers and local Rust developers. So in the next meetups, and I think Stefan will talk about the next meetups already, you will always see an international guest speaker on the one hand side and a local Rustician on the other side. Last but not least, it is important for us as the Coding Club Linz to be as inclusive and diverse as possible. This meetup is not just for professional developers, it's for students, it's for teachers, it's for hobbyists, it's for anybody who is interested in Rust as a programming language. And with that, Stefan, back to you.
Cool. A couple of housekeeping information. So if you want to chat with us, discuss with us, have questions about the talks, the meetup in general, chat with us on Discord. There's the Discord invite link. If you're watching on YouTube, the Discord invite link is just in the description, or check out the invite link on our webpage or on Twitter. So we are spreading the invite link everywhere. And please join us on Discord, because we are going to collect questions here, get with you into discussions, and want to have one central room where we can exchange our ideas and discuss and chat. Follow the YouTube link, Coding Club Linz, if you want to. Yeah, you're probably already on the YouTube channel. If you want to get updates on future live streams, or if you want to see other videos from the Coding Club, and stay up to date with the information we put out on @rustlinz on Twitter, or rust-linz.at, which is our webpage. And with that, I want to introduce today's talks. So I'm very excited to welcome Ryan Levick from Microsoft here at our very first meetup, because I don't know, I guess it was about a year ago or so, where Ryan joined us for our web development podcast Working Draft, to talk about Rust and about WebAssembly. I guess this was the connection that we made to justify a Rust talk in our HTML, CSS, and JavaScript podcast. And ever since, Ryan got me hooked on that topic. So I never had the chance to dabble around, fiddle around, as much as I would have loved to. But I never left the idea of not trying out Rust. And so from this point on to today, which spans a year, it was always Ryan reminding me that there's a programming language that I really should try out. And I did, and I love it. And that's why I'm super happy that Ryan is joining us. And Ryan is going to give the first talk of today, and tells us why we should care about Rust. Second is our very own Rainer. Rainer is going to introduce Cargo, Rust's package manager, where I also am very excited about, because yeah, I scaffolded a new project. I run build, but I'm sure that Cargo does a lot of things more. And I also want to introduce the upcoming meetups that we are having. So we have already 2 more meetups planned. One is on September 17, where we are welcoming Megan Lewis from Microsoft, who is going to live code with us a Rust application from. What was that?
Somebody forgot to mute his mic. Whatever.
Sorry,
Okay,
I'm not moving my mic, but I'm a huge fan of your channel.
Absolutely no problem.
Alrighty. Okay, so upcoming speaker on September 17, Megan Lewis, who's going to live code us a full application with Rust, like from scaffolding, building, debugging, and testing. So this is going to be really, really interesting. And please, folks, if you're not presenting, please mute your microphones. Please, please, please. Otherwise, we would have to do stuff. Or join us on YouTube. You can scream in your microphone at YouTube as much as you like. I honestly don't care. The local speaker is going to be Roland Druckerbauer, who is building with us a digital logic analyzer with embedded Rust. So Rust is also a great technology for embedded systems, and Roland is going to show us what to do there. Third meetup, October 8th. We are welcoming Valentin Tolma.
I think we should mute him.
Yes, please. We are welcoming Valentin Tolma from Google, who is giving an introduction to trades. I am so sorry. I'm just kicking you right now. I'm very sorry. Valentin Tolma from Google, who is going to tell us more about trades and how they are different from regular inheritance things. And a local hero again, Matthias Hayden, who has written a great blog post about writing a kernel driver with Rust, and is going to show us how this works. All right, and with that, I'm going to stop my screen and I'm going to do some Zoom moderation. Folks, what is happening with you? And I want to pass over to Ryan.
All right. Hopefully everyone can hear me.
Yes.
Great. Let me share my screen. Cool. So hello, everybody. Today I'm going to be talking about why you should care about Rust, maybe, or maybe you shouldn't. But hopefully after today, you'll have a better idea of whether you should or should not care about the Rust programming language. But before we get started, a little bit about myself. I'm Ryan Levick. As was already mentioned, I work at Microsoft, and in my day in and day out at Microsoft, I do everything related to Rust. So we actually use Rust more and more each day at Microsoft, and I'm happy to answer questions about that. But my official job title is as Cloud Developer Advocate. So working together with people inside of Azure, and it seems like somebody's drawing on my screen, which is not so nice.
We will get rid of that.
All right, thanks.
Sorry, just one thing. I'm really sorry, folks, since this is not working out. I would really love if you could restart your screen, please, because apparently some settings allow everybody to draw on your screen. I'm super sorry for that. I locked the meeting now. If something else like this comes up, I'm going to remove everybody, and please go also to YouTube then. And if you restart, it should work again. I'm super sorry what is happening here.
Okay.
So, folks, please stop that. That's no.
Let's see. Let's give it a try again.
Thank you.
See if I get drawn on again. All right. So yeah, as I was saying, Cloud Developer Advocates, and I do everything related to Rust. With that being said, I'd like to give a shout out to my employer so that I can continue to pay the bills. But also, there's a really great thing for those in Austria. There's a bunch of free learning resources, some classes that you can go ahead and learn about Azure. And as is the theme of the talk today, it's all about learning. So if you want to go ahead and take a look at that, then feel free to take a look at that link. And with that, we can get started. Before we really dive into why you should care about Rust, I want to have a couple of quick disclaimers for everybody, because when you're talking about how great a programming language is, oftentimes those conversations devolve into how terrible other programming languages are. That is not what I hope to accomplish today. So the first one is that there is no perfect programming language. Rust has a ton of flaws in it, just like every programming language. But learning those flaws is a lot of fun, and we'll talk a little bit about them today, but part of the discovery of learning a new language is to learn why it's not perfect. I think everybody should use what is right for the job that they have at hand, and it depends on what job you're trying to accomplish to know which tool you should use. And Rust could be a really great tool for a lot of different jobs, and I think one great thing about the language is that it actually does a lot of things really well. But there are some things it doesn't do so well, and there are other languages that do things better. So when you're looking to pick a programming language for a certain thing, don't just take somebody's word for it. Do a little bit of research, figure out what you think will be best for getting the job done. And when in doubt, use whatever makes you happy. So if you use Rust and it makes you happy, as it does for a lot of people, including myself, then it's in some ways reason enough. You don't really need to justify it beyond that. But if another language makes you feel happier than Rust does, then don't feel bad about using that. It's all about creating cool things, having fun, and we don't always have to worry so much about if we're using the right thing all the time. And lastly, learning can be an end, not just a means to an end. And what I mean by that is that sometimes it's just nice to learn new things, even if you don't have a reason to learn them. I have had several times in my career where I've learned new technologies, including Rust itself. When I first started learning, I didn't have a reason to learn it. I didn't need it for my job. It was 0.10. It wasn't even really usable for production yet. But I chose to learn it just because I like learning, and it's worked out really great for me. I now get paid to write in the language, but even if that didn't happen, sometimes it's just nice to learn, and it will have positive effects later on in life, and also can just make you happy. So let's not take this too seriously. So with all that being said, I'm going to go through several different languages that potentially you program in and day out, and talk a little bit about, if you are coming from that language, what you might like about Rust, and a little bit of what maybe you won't like about the language. So the first language we're going to start with is the C programming language, which is an oldie but a goodie. And C has been around for quite a while now and is used in a lot of things, but especially in kind of low-level use cases, and especially nowadays with the rise of C++, and then of course the rise of garbage collected languages like Java, C#, and then going on. Now we have a whole bunch of languages that we can choose from that we'll talk about later on. There's less and less need for a lot of programmers to use C, but it's still used a lot today for a lot of different reasons. And that might be things from microcontrollers to airplanes to operating systems, and a lot of different things are written in C. And that's really great. One terrifying thing about that is that C is a very dangerous language, and you can very easily make mistakes. And that's something that as a C programmer, you might love about Rust, is that Rust is 100% memory safe. What do we mean by memory safe? Well, if you've done Rust, C programming before, you know about things like use after free or double free. These are common mistakes that you might make when you're handling memory management. Because in C, memory management is completely manual, you as the programmer are in charge of it, you can make mistakes. And one graph that I like to show on basically all of my talks now is this graph. This is a graph of CVEs, so security vulnerabilities at Microsoft specifically, and the percentage of our security vulnerabilities that have to do with memory safety versus not memory safety. So a lot of C programmers out there are very proud, which is good, but they're very proud that they don't make mistakes. And if you make a mistake in C, it's because you're an idiot. We have proof that either most people are idiots or that everybody makes mistakes. And I personally don't believe that everybody is an idiot. I just think most people make mistakes. And so even if you think you are a perfect C programmer, the likelihood that you will always work with other people who are perfect C programmers is very low. And therefore, using a language where it is very easy to introduce memory safety vulnerabilities, and as we see across time, roughly 70% of those at Microsoft tend to be memory safety issues. This can be quite dangerous. And this isn't just Microsoft, but this particular data is just Microsoft, but when talking with Google, Apple, basically every big software engineering company in the world, the figure tends to be around this. And so this is why you see more and more companies looking into Rust, because we need secure software. And it is a bit of a shame that we're still using a language that where you can end up so easily introducing vulnerabilities. So I wanted to take a look at a little bit of code today, and if you've never written a line of Rust in your life, don't worry, we're going to go line by line here. But it's just don't get bogged down in the details. Just let it kind of wash over you and give you a chance to see what programming in Rust kind of looks like. But hopefully this will give you an idea of what that looks like. So up at the top of the screen, we have a person struct, and just like in C. Your person struct can have fields in it. And we have two fields, name and age. And name has a string attached with it, and age is a 8-bit unsigned integer that we have here. And we're going to talk about this like single quote A thing right here. This is kind of the whole point of this exercise. Most of the time you won't see this kind of weird syntax, but for our purposes, for this example, it's very important actually why this tick A, as we like to say, is here. And then we're going to have a parse function, which takes in a string and returns back an optional person. And if you've ever done any parsing before, you know that parsing might not work. The string that you're passing in might not actually be parsable. And that's what this option here is. Option is simply a type that wraps another type and says you either have that type or you don't. Now in C, you probably would use I don't know, maybe a null pointer or something like that, or a special value. In Rust, we're very explicit about everything, and you tend to not have special values in Rust. You tend to either have a value or you don't. And this is what our parsing code looks like. It's very easy to see what it does. We initialize name and age to both be none, so we don't have a name and age when we start. And then we get the lines from the string, and this is just a simple function that breaks up our string based on new line characters. We map over that string, so for every single line, we do something to that string, and what we do is call the trim method on it. And what trim does is remove white space from the beginning and end. So by the time we have this line here in our for end loop, what we have actually is a single line at a time that does not have white space at the beginning or the end. And then we ask if the line starts with name : then we go ahead and get the rest of the line, and that is our name. And we wrap it in the sum, which means, hey, we now have a name. And the same for age. If the line starts with age : then we get the line starting at right after age, and we trim off any extra white space that we have there, and that's our age right here. And so what you can see with this is it actually seems quite high level. And we'll talk about this later on in the talk, but the great thing about Rust is this code does seem rather high level. And in fact, I tried to write it a little bit low level so that it wasn't too weird looking for a C programmer. But at the end of the day, Rust code tends to be high level, but it compiles down into code that performs and generally works just like it does in C. This week I've been doing a lot of embedded programming in Rust, where basically every instruction counts, and even there we get to write this kind of really high level code, and it ends up turning into code or assembly code that resembles what you would get if you were to use C instead. And so that's kind of a theme with Rust. You can have your cake and eat it too. You don't have to make a lot of the trade-offs that you've had to make before. Then at the end here with the question mark, that's simply saying if the name's not there, return back a none at the end, and same with age. We parse the age as a number that we have right here. And so at the very end, we end up with a person, and otherwise we would have propagated out are none here. So this is very high level code that we have here, but again, it compiles down to pretty efficient assembly code, something similar to if you were to have written it in C. But what happens if we do something silly like this? And of course, all the examples that I'm going to be showing today are quite simplified. The reason for it is I don't want to spend half an hour explaining a complex example that you would run into a real world, but hopefully you get the idea, even with simple examples here. We, in this code right here, we create a stack allocated string that contains our kind of unparsed person content here, and then we call the parse function here. Now, if we go back to the previous code, what we're saying with this tick A line here is that the lifetime of person is attached to the string that's inside of it. So however long this person lives, then the string inside of it needs to live at least that long. And this is a great thing about Rust if you're coming from a C or a C++ background. These concepts that you've thought about before around lifetimes, for instance, are really formally baked into the language. So in C, you often think about I allocate something on the heap and I need to free it at some point, and that the length of time in my program that it lives until I free that memory there is its lifetime. But in C, that's just in your head or in documentation. There's nothing in the language that really enforces a certain lifetime. It's just simply when I call malloc and when I call free is its lifetime. But in Rust, we actually have that baked into the language. And so this on the parse line here says the input string is a pointer to a string, a reference in Rust parlance to a string, and its lifetime is tied to the lifetime of the person that we get out. So however long the string that we pass in needs to live, the person that we get out from this function needs to live at least that long, at most that long. And this is enforced by the compiler. So when we write something that should not work here, we allocate this string here. The string is living on the stack here. By the time that it gets to the end of the function, in Rust, you don't have to explicitly call free. It gets done for you at the end of the function, just like in C++. If we were to do this right here, we would return out a person that is tied to the string which has been allocated on the stack. And that, if you're a C programmer, you should be going wrong. You're going to have a dangling pointer here. We're going to at the end of this function free our string, but we're going to return a person which is referring back to that string that has now been freed. And that you can't do that. This is a bug. In this case, happens to be a very easy bug to see. But you can imagine much more complicated code, and Rust will statically enforce this. This is all static. There's no garbage collection. There's nothing going on here. It's just a static check here that's happening. And in fact, this is the error message that you end up with here. We cannot return a value referencing a local variable, which, if you're coming from a C background, should probably seem pretty straightforward. Okay, yeah, I know. I can't return something that refers to something that's been allocated on the stack. That's wrong. Well, now you have a compiler to always make sure that you never make that mistake. And that's really great. And as we saw in the back here, it seems to be an issue that that a lot of developers actually make, and ends up in a lot of pain for big companies like Microsoft. And what's really great about this language is that theoretically, if we were to use Rust for everything, all 70% of those bugs would just go away, and we would only have to deal with the 30% that remain, which is, if it's not really practically possible given the amount of C and C++ that exists in the world, but theoretically we can start working towards that goal of getting rid of 70% of bugs that exist today in our most fundamental systems. All right. Yay, we can party as C programmers because we never have to segfault again. We never have to write something that, we never have to get in our debugger because we hit a segfault for some reason. And in fact, in Rust, by default, there is an escape hash we can talk about. But by default, if you write Rust, you will literally never, ever have a segfault unless you had you're using a buggy library or something like that, or the standard library has a bug in it, which I don't believe the standard library has had a bug that could segfault in a while now. So you never have to worry about a segfault again, which is really great. All right, what about C++ developers? Rust definitely has a lot more concepts that kind of go in with C++, and in fact, this whole thing about dropping at the end of a function, it kind of reminds you of the RAII pattern that you have in C++. You can just imagine, take away all the baggage of kind of older C++ and only have the kind of newer, more safe, more high level concepts that you have in C++ nowadays. So you end up with a dramatically simpler language than C++ is, with all the benefits, and there's really no way to mess it up because there's no kind of older code styles that you have to worry about. So as a C++ developer, I think what you're really going to love, besides all that memory safety stuff, is the default build tooling that Rust comes with. And I know we'll talk about this in his talk coming up. A lot of it has to do with Cargo, the build tool, but we're going to take a little bit of a look like that. Here's us testing our function that we had from before, our parse function here. And you can see in this code, built into Rust already is a way to write unit tests. And this is default. There's no extra thing to download from Google or whoever. You just get it right out of the box in the default tooling, and you can run tests. And of course, the CFG at the top there is a compiler flag, which means at the end of the day that when you actually build this for production, this all just goes away. So you don't pay a price in your end binary, and you get to run your tests, and you get this nice test output. Where you can see that our tests pass, which is really great. We don't have any doc tests, but there are also documentation tests as well, because documentation is built in, and we're ready to go. And in fact, when we build our program, we just have to cargo build -- release here. And as a new Rust programmer, don't forget the -- release if you want to do some benchmarking or something like that. That's a common mistake that people make. By default, Cargo builds in debug mode, which has optimizations largely turned off. So we can go ahead and build a release build of our binary here. And Cargo also comes with run and a bunch of other features that I know we'll surely get into later on. So that's really great. And in fact, here we have our cargo.toml file, which is a file that describes our project. And it's a very standard file that everybody in the Rust world knows about. So you don't have to learn different build tooling systems and, what's the next flavor of the month. Cargo is it, and it's here to stay. And you can add dependencies very easily. You see on line 8 here, I've added the nom library, which is a great parsing library. If we don't want to do parsing ourselves, but rather want to use a library to do that, it's as simply as adding this one line. Then what Cargo will do is go ahead and fetch the dependency and all of the dependencies that dependency uses as well, build them for you. And there's, I think, a lot of reasons why C and C++ programmers try to avoid dependencies is because you end up with a lot of build headaches because of that. But in a world where you have kind of standard build tooling, then you can end up in a great situation where, especially in the beginning of a project, pull off some things from the shelf, go ahead and get your project running. And you know what, if you don't want to have that many dependencies at the end of the day, that's fine, but you can start with those and then get rid of them as you go along, if that's, if you need to, if you feel the need to. But this is a really great way to get up and rolling, and it's all built in out of the box. You don't have to kind of configure anything. It all just works, which is really wonderful. All right, so we talked about the C and C++. I think, by the way, C and C++ are the languages that I would most strongly encourage people to give Rust a try. The reason for it is because Rust is explicitly trying to fill the same kind of areas that C and C++ currently do. It wants to be a language for writing operating systems, for writing web servers, and by that I mean something like Nginx. It wants to build low-level systems. It's a systems programming language, and that is the area that C and C++ currently occupy. The next languages we're going to be talking about, Rust can do a lot of the same things there, but it's definitely not it's first and foremost goal to kind of compete in the same space. But for C and C++, it definitely is. And so, give it a try. Why not? Yeah, I think you'll like what you find there. So now we're going to be talking about C# and Java. The reason that I combine these two together is because they're both garbage collected languages. They both are object-oriented languages. They come from the 90s, early 2000s. So they have a lot in common there. And one thing that I want to talk about there is thread safety. Now, C# and Java have garbage collectors. So this whole thing about memory safety, you don't have to worry about that with C# and Java because you have a garbage collector to take care of that for you. But what you don't get in C# and Java that you do get in Rust is the idea of thread safety. So Rust by default is 100% thread safe, meaning that you don't get any data races happening. You never have unsynchronized access between two threads to a piece of data. The language guarantees that you have synchronized access between things in memory. And so I want to show an example that has nothing to do with threads, but I think because threading can get a little bit complicated, I wanted to boil it down to something that I think is related to why Rust works this way. And here is a thing that actually, I haven't done this in C#, but I know in Java throws an exception. We take in a vector, which is basically an array, and we're looping over it. And we decide if the item that we currently get from that vector is above 5, we're going to push a new item onto that array. If you've programmed in Java or C# before, or probably any programming language, you might know what this bug is. This is a concurrent modification error here, which typically in other languages would be a runtime exception, where we would detect, oh, you're trying to change the thing that you're currently iterating over. Well, in Rust, you can see on line 4 there, barely, that there's a little bit of a squiggly line there. It turns out that in Rust, the compiler stops us from doing this, where we cannot, while we're iterating over an item, push something onto it. And the reason I wanted to show this example is because there are a lot of things that fall out of Rust's ownership model, the borrow checker that you may have heard stories about, that allow you to write code fearlessly, where you can write something like this, and if it's a terrible idea that actually this would end up corrupting your vector as you iterated over it, the compiler will stop you from doing it. This code just does not make sense. And the compiler tells you, instead of waiting for runtime checks to catch that error. And the same thing with threading. You have no data races that you have to worry about. And because of this, you get this fearless concurrency, where if you need something like a mutex or some other concurrency primitive to make sure that data is synchronized between threads, the compiler will tell you, hey, you're not doing this. And if you think that you're smarter than the compiler, which most of the time you're not, I've learned that the hard way. There is an escape hatch that you can go for, but 99.99% of the time you don't need that escape hatch, and the compiler is correct in telling you you're doing something wrong. All right, now we're going to be talking about Go and Node. I picked these two languages because they're kind of like server side and 5-10 years old now. Used for a lot of web servers and stuff like that. People compare Rust to Go all the time, probably because they came out around the same time. Go is only 3-ish years older than Rust is. I would argue that Go and Rust are very different languages from one another, meant for very different things. But one thing that I wanted to talk about as a Go or Node developer is the robustness that Rust can offer, and a robustness that these other languages don't make a point of trying to provide to their users. This comes through a powerful type system. Robust error handling. So if you're a Go programmer, typically the old joke about Go is that you have to check for nil every other line. Rust does not has much more kind of succinct error handling than that. Also, we talk about Go not having generics and things like that. Although it's coming, of course, Rust has that baked in, And also there's a kind of rough mentality in Rust that, if it compiles, it works. And, of course, this isn't true, but sometimes it feels true for sure, where you spend a lot less time debugging your programs. Now, when you're learning, you're going to spend a lot of time fighting the compiler and getting your code to compile in the first place. But the good thing is that as you learn, that happens less and less. And so one quick negative part about Rust here for Go developers that I think in particular will not find that great is that Rust is definitely not as simple of a language, or is not as small of a language. There are more concepts that you have to learn in Rust. And the reason for that is because Rust is trying to do something very different than Go is. Go is particularly made for server-side web applications, and Rust is made for low-level systems. And so there's a lot of things that the Go language can kind of abstract away from you and give you good defaults that Rust can't, because it needs to give you the control that you need in order to use it as a systems language. And so we'll talk a little bit more about that in just a second, but something to look out for. Here's an interesting example of this robustness. This is reading to a string here. This is a re-implementation of the standard fs read to string function here. Takes in a path and it returns an IO result of string. Now this IO result, as you maybe can even tell, it's a result of doing an IO operation. Can either succeed or can fail. And that makes sense, right? Reading from a file system can succeed or fail. So it would be strange if it only returned back a string. And Rust doesn't have exceptions. So we can't just throw an exception and document, hey, this might throw an exception. Rust is very explicit and says this thing might succeed or fail. And you know that on line 8 by seeing IO result there. And then on each line, we kind of follow the happy path where we're opening the file, we allocate a string buffer, we read to that string buffer, and you'll notice on line 9 and line 11 there, the question mark at the end. And that's our error handling for this file. We basically want to say, if at any point there's an error from doing this thing, just bubble it up to the user. And just with one little character, we get to say on line 9, for instance, open the file, and if it fails, just return back that error to the caller of the function. And so you get the kind of nice shorthand of writing code like it had exceptions or something like that, but the robustness of knowing that the caller of this function can't forget to catch the error because they are forced to deal with the fact that there is an error, or they can pass it along to somebody else. But the robustness is there for guaranteeing that that error is dealt with in some way, even if it's just a tilt of a hat to say, I understand you can error and I'm going to pass the problem on to somebody else. That's what the question mark operator does there. All right, now we're going to be talking about Swift and Kotlin as two languages, kind of very, very modern languages, two languages that I in particular have really enjoyed programming in the past, in particular for iOS and Android development. And I think what you'll love if you're coming from these two languages is the control that Rust offers you. This is sort of the opposite of the reason that you probably love Swift and Kotlin. Swift and Kotlin have really great abstractions that allow your code to still be very performant, but you don't really have to worry that often about things. The languages do a really great job of kind of abstracting over a bunch of common concerns like memory management, for one. And you can kind of focus on your core programming. But the unfortunate part of that sometimes is sometimes you need to know exactly what's happening in the machine. You want to know how many times am I allocating to the heap? Is this variable going to be on the stack or on the heap? And in these other languages, sometimes you know for a fact that it will always be on the heap in the case of a garbage collected language generally. Or you're not sure, it might be stack allocated, depends on the optimizer, blah, 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 blah. When you're doing low-level systems programming, you need the control that a language like Rust can afford to you. So it's really fine-grained control over allocation, zero-cost abstraction, so you still get a lot of these really great abstractions that allow your code to be elegant, readable, maintainable, where you're not writing 1,000-line functions to do one small thing. But at the end of the day, you know that your abstraction doesn't cost you anything, or it's very clear about its cost, so that you know ahead of time how much you're paying in terms of performance, speed, memory consumption, and so on and so forth, when you're using these abstractions. And in other languages, like in Swift and Kotlin, sometimes that can be unclear, or you have to be an expert in the language to really understand it, and it might change from one release to another, and you have to always keep on top of this. Most of the time, you don't want to worry about that, but when you do, it's nice that you have a language like Rust where you can know exactly what kind of runtime performance you're going to get. And at the end of the day, you're still going to have sensible defaults. So most of the time, you don't have to worry about this stuff. But when you do want to worry about it, you can worry about it, which is really great. All right. Now to go to a really different language, Python and Ruby. My very first language that I ever learned was Ruby, where I learned Ruby on Rails back in the day, and still have even though I don't write any Ruby anymore whatsoever, I still have a fond place in my heart for Ruby, just because it's so fun of a language. And I know a lot of people also enjoy writing Python, although I've not really had the pleasure of doing much Python. I think what you'll love about Rust is it's fast. That's typically what comes to mind when you're thinking about Ruby and Python, is that they're not the fastest languages in the world, because typically they don't need to be, except sometimes they do need to be. You know, if you have a Rails application running out there, you have a Django application, or you've got a machine learning model that you worked up in Python, in a Python script real quick, and now you really need it to be quick. It would be nice if you had a language that could interact very easily with your Python or with your Ruby, and allow you to write safe code where you know that you're not going to get in all the icky problems that you would get into if you were to write C or C++, which causes a lot of Ruby and Python developers to stay away from native extensions to their packages. It's nice that you would have something like that in Rust. Rust is fast. It's a very fast language. It's generally in the same ballpark as C and C++. And in fact, sometimes it's even faster. And, you know, how can that be? Isn't C the fastest language in the world? No, it turns out that C cannot make a lot of optimizations inside of the compiler because it just doesn't have enough information to do so. And it's a real testament to how amazing a lot of C and C++ compilers are, that they're able to take a language that is very loose in its rules, and able to get it up to, are able to do some of the optimizations that they're able to do. In Rust, there's simply just much more information available to the optimizer and the compiler. And I don't want to say that Rust is fully taking advantage of this at the time, at the current moment. But I think the theoretical upper limit of performance for Rust is higher than it would be for C and C++. Let's see if one day it achieves that, but you can know that you're at least getting kind of in the same realm as C and C++ when you write Rust, which is nice to know. And you know, why would you give up your beautiful Ruby or beautiful Python code for another language? Well, you want to do it to get some performance. So it's nice to know that you'll get that with Rust. A quick shout out to a project that I've actually not used before, but I think it's so cool. There's different ones for different languages, and I picked this one because there's been some tweeting happening about it lately. This is the PyO3 crate. Crate is the term for Rust package. And this allows you to write Rust code and easily embed it into Python, or to embed Python in your Rust code as well. And it's really great. This is what some example code looks like here, where you can just simply annotate a Rust function with Py function, or a Rust function with Py module, and then be able to add, you know, native Rust code into a Python module, and to be able to use it simply from Python, even though it's implemented in Rust, where you don't have to deal with the you know, nasty C FFI that you would have to do manually if you're writing this in C, or if you were to do the thing manually in Rust. Even you get a nice abstraction over that allows you to write these Rust functions and use them from Python, and in a very easy way. So I think that's really cool. And there's projects like this for Ruby as well, and other languages as well. So something to check out if you're looking for a reason. Maybe you can take a look at rewriting some slow part of your application that's in Ruby or Python and write it in Rust and see if you get a performance gain from that. All right. And I think the last one that I'm going to be talking about is JavaScript and TypeScript, two also fantastic languages that I have written a lot in my career, and I've thoroughly enjoyed writing. I think what you'll really love about Rust is that you finally get a choice. For a long time, really the only way to write a front-end application in particular was to use JavaScript. And of course you had CoffeeScript and you have TypeScript, but those are just, pretty face on top of JavaScript. They're not too different there. And, if you're adventurous or something like that, you might use something like Elm, which I've also enjoyed using. And there are more here, but I think what's really interesting is using Rust as a front-end language through WebAssembly. And in fact, that's something that I've done in a project before here, writing a Game Boy emulator in Rust and embedding it. And this is a browser page here. I gave a talk about it at a Ruby conference 2 years ago, so you can look for that on YouTube, where I talk about building an emulator in Rust, putting it into a web page. And of course, the UI is still in TypeScript. You can write it in Rust. It's just a little bit more, there's not a ton of reason to do it, but it is fun, and the whole thing could be in Rust. I decided to mix and match, and it's a fun thing to write something like this in a new language and have it work in the browser, and everybody can use it. So that's really great. So with all that said, there's a couple of things that I want people to be a little bit careful about when they're learning Rust. As this lady here is having a great time on her skates, but she makes a little mistake and falls over there. That's definitely possible to do in Rust as well. So a couple of words of advice here. Rust is not Go. Rust is not C++. Rust is not C. Rust is not JavaScript. Rust is not Swift. This is fine. These languages exist for a reason, and they're all great in their own right. And so why would you want another language that's just like the language you already know? Some words of advice to you when you're learning Rust for the first time: take it slow. Rust is not a simple language, but it is a language that makes a lot of sense. So you just have to learn the rules. But in order to do that, you got to take it slow. You got to learn the basics before you start hacking. If you just go into Rust and without reading the book or listening to any tutorials or something like that, you're setting yourself up for frustration. So take a little bit of time to learn the basics before you really dive into hack. There's going to be plenty of opportunities to hack in the future with Rust, but at first, just learn the basics, kind of the old-fashioned way. And reach out for help. I think this is the best part about Rust is the community is so wonderful. And I'm happy that we have more meetups like this in Linz that we can be a part of. There's a ton of resources online, a ton of really great people who you can reach out to, and I'll give you some resources in just a minute. Don't be afraid to reach out. And if you have a bad experience, come talk to me. I'd be happy to help out as well. I really want everybody to be happy and comfortable in the Rust community. And I think that we in the Rust community are doing a good job, and hopefully we'll continue to do a good job and get better at making it an open and happy and good and safe place for people to learn about computing. Here's a couple of resources to take a look at here. The Rust Programming Language by Steve Klapnick and Carol Nichols is really great. It's free, that's why I put it up here. There are other awesome books out there that you can take a look at, but this one you can just hop on and check it out real quick before you decide to buy a hard copy of it. There's also the Rust language website, which has a learn section with a whole bunch of different things like the Rustlings course, Rust by example, and a lot of links to places like the Rust Discord where you can get help and stuff like that. So check that out. A shout out to this really great guy, Ryan Levick. Not sure where he's from, but he does some awesome streaming on Twitch, and you should definitely check him out. There are other people out there also doing amazing Rust streams. So there's a whole community. Come find us. Let us know what you'd like to learn about. I've been doing a lot of kind of intermediate Rust programming streams lately. But if you're interested in a beginner Rust stream, it's something that I'm thinking about doing. So just let me know. And with that, I think we still have a little bit of time for questions. I'd be happy to answer any questions that you have about Rust from any background that you might be coming from. And I hope you enjoyed my talk today. So thank you very much.
Thank you very much, Ryan. We definitely enjoyed the talk. The Discord channel was running over with messages during the talk, especially when you showed the C slide. Everybody was posting their favorite programming language, ranging from assembly to PHP. So like the whole spectrum.
Very nice.
Do you have anything what assembly or PHP developers would love about Rust?
I think for PHP developers, it's probably the same as for Ruby and Python. So you kind of get kind of the same thing happening there, which is really great. And for assembly programmers, I guess you get to use a high-level language. Maybe you don't like that if you're an assembly programmer, but yeah, come join the rest of us where we have curly braces and if statements, and you don't have to worry about registers too much. So.
Absolutely. There were a couple of questions in the chat. If it's okay, I just passed them along.
Yeah.
Okay.
Yeah, sounds great.
So one very interesting question is, in what ways is Microsoft actively developing using Rust?
Yeah, so we've written about this a little bit in the blog for MSRC, and I'm going to go all the way back to the beginning of the talk and go back to this graph that I showed here. This is actually from the MSRC, the Microsoft Security Response Center, which is the team in charge of security response at Microsoft across all of our products. And about 2 years ago, they took a look at this graph and got very sad and said, we've been putting a lot of money into making our software safer, which has been working. We find a lot more vulnerabilities ourselves instead of bad people finding them before we do, which is good. That's good. But wouldn't it be great if this number didn't, if this didn't exist and we didn't have to worry about finding them before the bad people did because they just didn't exist in the first place. And so looking at this number where you see 70% of the security vulnerabilities are memory safety related, and that from 2006 to 2018, and by the way, 2019 was the same. We didn't update the slide, but it's the same percentage, roughly 70%. The number's just not going down. How can we do this? Well, one possible way to do that is adopting a language where you literally can't write memory safety bugs. That could be using C#. And so one aspect of that is let's use more C#. Let's use more garbage collected languages. They get rid of a lot of these issues as well. But we're writing Windows, we're writing Office, we're writing Xbox games, microcontrollers, we're writing firmware. A lot of these things, C# is just not going to probably be the language that you want to use because of its garbage collector. And so we need an alternative. And so we went out in the world and found Rust as the best alternative that we can adopt. And Microsoft is a slow and big company, as most big companies are. And so we're not going to rewrite everything in Rust tomorrow. But little by little, more teams are adopting it. I can't say, I really wish I could say which teams are adopting it right now, but we're still not quite ready to make that public. There are a few like Azure IoT, that they write IoT devices as well as web servers that help you manage those devices. They are active open source users of Rust, so that's no secret there. But there are other teams inside of Microsoft that are starting to use Rust and really seeing great results with it. And if we could just get my colleagues to write blog posts quicker, then at some point we're going to be writing a lot more about that, and we can start discussing which teams are using it. But I can say that not only are we seeing great memory safety advances, we're also seeing performance gains, which has been really surprising. Now, if you were to rewrite some of that code in C++, modern C++, or the latest way that you would write it in C, maybe you would see the same improvements. But the good thing is that it's not all about memory safety at the expense of something else. It's basically just positives that are happening with our adoption of Rust. And so it's making the pain of adoption, which comes from adopting new tools, learning new things, taking on new build systems, blah, blah, so on and so forth. It's making that worth it. And so the experiment has been very positive to this point, and hopefully we can share more about that in the near future.
When the big announcement comes, we are pretty sure that everybody in this room is going to say, that's what Ryan meant back in the day. Regarding the slide that you just have open, Vladimir wants to know if you have any idea what happened between, what are the numbers, 2009 and 2011 and 2012 and 2014? I guess where those big spikes are in the graph, if there has been something that changed or that got attention.
No, I don't have an answer to that. I think maybe my colleagues at the MSRC might be able to give a reason. I do know from what they've told me before that for some reason, security vulnerabilities tend to come in waves. And they're not sure why that is, but it seems that when you find one issue, that tends to lead to others finding other related issues. And so that can lead to things kind of increasing in number, and then you hit a drought and then it increases in number. So maybe it has to do with that, but I'm not sure.
I have two more questions in the chat. One is from Matthias, who says that you showed screenshots using VS Code, and if you have ever checked IntelliJ, and why are you using VS Code?
I'm using VS Code because I work for Microsoft, of course. No, I actually a long time user of Vim and decided to switch to VS Code because frankly, that's what a large portion of the Rust community uses. Every year there's a Rust community survey. And I think for the past 4 years now, VS Code has been the most popular editor in the Rust community. And it's a great editor. I say that as a Microsoft employee and also as just a person who uses editors. It's a great one. I've not had the pleasure yet of using IntelliJ. I've heard some good things about it, and I believe the person who is now writing what will soon be the official Rust language server implementation was the original author of the IntelliJ plugin for Rust, and so it's all just a big party, and everybody's everybody's having a good time. So I think probably IntelliJ would be fine to use if that's what you're used to.
Very cool. Yeah, this is something that I noticed when starting with Rust, that the community takes care of a lot of things. So everything runs down to the same, if not people, the same organization, and everything is collected at one place. And this was very, very inspiring. I haven't seen that in any other programming language so far.
Yeah. That's something interesting to point out real quick is that although Rust was started as a Mozilla project, for Firefox, or originally for Servo and then for Firefox, and there's still a lot of people who are employed by Mozilla to work on Rust. It is largely a community collaboration, and even for people like myself who are employed by Microsoft and go into the Rust community, we're in some ways first Rust community members, and then employees of our employers second when it comes to Rust. And I think that's really great, just because there's not a lot of this kind of corporate infighting between the different parties in the Rust community. Now, that might change, in the future, but Rust is getting more and more popular every year, and the kind of core of the community, the core ethos of the community has remained the same over that time. So I'm quite happy and hopeful that the Rust community can maintain this kind of real close-knit sense, even as the Googles and the Microsofts and the Facebooks of the world come in and start participating as well.
Cool. One last question before we switch over to Rainer. There has been a research project called Verona, a language project from Microsoft Research. How do you see Rust's future regarding Verona being on the horizon? Is it something that competes with Rust in that regard, or is it just a research thing that might go nowhere?
So Verona is a really cool project. It's part of the effort at Microsoft that I'm a part of to make systems programming safer. And for those that don't know, it's a project by Microsoft Research for looking into how to make systems programming safer. Now, why does Microsoft Research do research projects is a good thing to talk about. They do it for multiple reasons. One is they do research, and literally we pay them to learn more about stuff. And I think that that is the best way to classify Verona at this current point in time. It is a research project. Try and use the compiler today, and this is not meant to disparage the team. They're doing fantastic work. But it's definitely a research project, and that's fine. It's meant to be that. It's meant for us to learn more about it, because it's the way that it handles memory safety is very different from the way that Rust handles it. And if nobody did research, then we would never, learn new ways to do things. So this, I think, is very important that we're able to, without worrying about fitting it into the Rust programming model, without fitting it into an existing language, the team is allowed to just create a new language and see what kind of comes out of it. Now, what will be the future of that? There's a lot of things that have happened in the past with Microsoft Research projects. The most common one, unfortunately, is that they just get shut down because they've learned stuff and they don't need it anymore. Another one is that it gets folded into existing things. And the third one is that it gets fully productized as its own thing. I could see Verona becoming any one of those things. If it gets folded into something, I think I would love to see some of the ideas get folded into Rust, and who knows, maybe that will happen in the future. And if it gets productized, I am definitely a language pluralist. I believe that more languages is a good thing. And so, and I know what the team is trying to achieve with Verona is not to take over Rust. It is a very specific aspect of systems programming. So even if in some chance in 5 years from now or whenever, Verona becomes a thing, a productized actual language that you can really write production code in, I would be very, very surprised if that threatened the Rust position in the industry today. And I'm not worried about it at all. In fact, I hope that we see a lot of things come from Verona, because it's a really cool idea and a really cool project. So.
Cool, very cool. Ryan, thank you very much. This was an amazing talk. This was an amazing chat. I could talk for hours with you on that topic, but we also have to let Ryan speak on the next topic. Folks, Ryan is in our Discord. So if you have any more questions, I'm sure he's eager to answer them. And with that, I want to say thank you, Ryan, and let's move over to Rainer. Two things that I learned in the meantime regarding the troll that we had earlier on. You are now all unmuted until you're all muted until I unmute you. So this should take care of the screens, and every presenter is able to disable annotations so other people can't draw on their screens. This is stuff that I just learned. And I also learned that webinar licenses are a very good idea if you have a live meetup. But hey, that's that. I'm now really eager to learn more about Cargo, Rust Package Manager. I'm a Node.js developer. NPM.
So you love Node modules, right?
Oh, I can't tell you how much.
And you finally want to know where you find Rust's Node module folder.
Yeah, so the thing is, absolutely. So the thing is, you look at concepts and you see lots of similarities. Now I'm looking at the differences, and I'm very, very interested. So Rainer, the stage is yours.
Thank you, Stefan. Thank you very much. Thank you, Ryan. Again, thank you for speaking at our new meetup. You kicked this meetup off with a great talk, and Now I'm second, and I would like to talk a little bit about Cargo, Rust's package manager, build tool, and so on. So the next, let's say 30 to 45 minutes, we will see. I will show you a bunch of things you can do with Cargo. This is probably, if you have written a lot of Rust already, I will not tell you so many new things. If you are rather new to Rust, and you maybe just started with 1 or 2 Hello World projects, then I hopefully will be able to tell you a lot of tricks and behind the scenes stuff about Cargo and so on and so on. Before I go any further, I have posted the material, the link to my material, the slides, the samples, and so on in the GitHub and in the Discord channel. Everything is MIT licensed, so please take my slides, use them, share them, build on them, whatever you want. All the content that I will show you in my presentation is available. Oh, this link only works in GitHub Live. Everything will be available in Markdown, so take it and maybe translate it into whatever you want. And you have all the samples in the sample directory on the GitHub repository. Speaking of GitHub, this is the repository where all my material lives. So here you can see the slides. This was the link that didn't work before. Copy them, do whatever you want with them. And here you see all the samples. So if you want to recap things that I do here in this talk, take a look at this GitHub repository. And with that, without any further ado, let's jump right into it. And the first part, let me get rid of that one. I forgot to quit this. Yeah, now it's good. Okay, everything's fine. The first part will be for beginners. Okay, well, it will be for people who have not written so much Rust, but I hope even the first part will show the more experienced Rust developers some new tips and tricks. And then in the next chapters, we will dive deeper into Cargo. So first, let's quickly introduce Cargo. Let's keep that very short and to the point. It's a dependency management system. You manage your Cargo, your Rust dependencies. Dependencies are called crates. In Cargo, crate, we are here in a German spoken country in Austria. Crate is a Kiste, a Holzverschlag. This is what a crate is all about. So when we're talking about crates, this is the name of Rust's dependencies, packages. But Cargo is more than just dependency management. It's also a helper to invoke the Rust compiler, the documentation generator, and so on and so on. So it's a tool that makes it simpler to pass all the necessary parameters to the Rust compiler and associated tools. So if you would like to start something from scratch, you just say Cargo new, and then you give it a name. Finally, you specify bin or lib, depending on whether you want to create a program or a library. Next, you go into the generated directory here. You call Cargo build, for instance. By default, this uses the profile def. You can define the details about different profiles with Cargo, but the default profile creates a debug version of your code. And then you can simply run it. And where can you run it from? The target folder. So if you run Cargo build, you will find a new folder, target. There you will find the name of the version you are generating, debug, release, whatever you are looking for, and finally the executable. And here you see how you can run this one with Cargo build release. This now enables all the different optimizations and so on. And finally, you can run the release version. Please note here, the link here, if you want to fine-tune the different profiles for Cargo, take a look at this link. I only have 45 minutes or so today, so I cannot tell you everything about Cargo. You still have to do a little bit of research, but the least I can do is give you some links where you can read more details if you need that. Okay, this is a very quick introduction of what you can do with Cargo, but there is much more. Here I've put together a table with the most important Cargo commands. Cargo new obviously creates a new package, can be a library, can be an executable. Cargo search searches for a crate in crates.io. We will talk about this website in a second. Cargo tree displays a nice tree visualizations of all your dependencies, because you might depend on a crate that depends on a crate that depends on a crate, and so on. And this gives you a tree-like visualization. Cargo build obviously builds the current package. Cargo run runs the current package. So you do not need to type target and debug and name of the executable. Just type cargo run and you're done. I will show you that in a demo in a second. And finally, cargo fetch. Cargo fetch is somewhat important because sometimes if you are traveling a lot, well, not now in times of Corona, but later on when you travel a lot, like me, for instance, and you would like to work on your project while you are offline, maybe on the plane or on the train or something like this, just call cargo fetch. It will fetch all the dependencies from network. And that means you can later on run cargo run and cargo build without ever touching the network. So cargo fetch is important for people who are traveling a lot. Good. That brings me to the typical file layout of a project. Let's zoom in here a little bit. Here you see one important file that we will work on a lot in the upcoming 30 minutes or so. It's the cargo TOML file. They define some metadata about your application, the author and the license and a lot of other stuff, and of course, your dependencies. Once you call, for instance, cargo build, a cargo lock file is generated. Maybe the Node.js developers, does that sound similar to what you already know? Yes, cargo TOML is very similar to package JSON, and cargo lock is very similar to package lock JSON. So the cargo lock file is generated by the cargo tooling when all the dependency resolution is done, and cargo lock contains a lot more details about the dependencies, the detailed versions and the dependencies of the dependencies and things like that. It is responsible for repeatable builds. So if you just take cargo TOML, you don't get a repeatable build, but if you take cargo lock, you can really ensure repeatable builds. And also it makes the tooling faster. On the same directory level, you also have your source code. It's here. You can add some benchmarks. Yes, cargo and Rust have a benchmarking mechanism built in. You don't need third-party tools for that. You can add examples. And I personally, when I got into cargo, I found this one a very interesting one. There is a dedicated mechanism of adding example code. You know, this comes in very handy for me when I build libraries. Then I typically do a kind of, let's say, example-driven development. I design my libraries while I am thinking about different scenarios that my library should fulfill. And now I can write the example code in the same folder structure, and it fits in nicely into the whole project structure. I really find this one very interesting. And finally, here we have the tests. But important one, it's called tests, but it doesn't mean unit tests. If you read tests directory, it means integration testing. I will show you later an example how a unit test looks like and how you can run unit tests with cargo. Okay, let's talk a little bit about the cargo TOML file. I already mentioned it's similar to NPM's package JSON file. If you have never written JavaScript or Node.js or TypeScript code and you don't know what package JSON is, don't worry. You don't need to know that. But those of you who have, you know what I mean. The file has to be called cargo TOML with an uppercase C. That's defined, okay? TOML, it stands for Tom's Obvious Minimal Language, short TOML. You can follow the link here in my slides. Just go here and you can read all the details about TOML. I think it's very obvious. Everyone can read it. It's super simple. That's it. Just remember, the file has to be called cargo TOML, not anything else. It's built on semantic versioning. So if you add a dependency to cargo TOML, you also add the version number of the dependency you would like to depend on. And this is built on semantic versioning. So again, here I added the link. If you have never heard about semantic versioning, that is my homework for you. Read this document. Semantic versioning is super important in every modern programming language that I know. Okay, so here is the link. And everything is built on semantic versioning here. You also have some package metadata, and it looks like this. This is typical package metadata. It's the name of the package, the version, the author, and the edition. The edition is something that that beginners with Rust are sometimes a little bit confused. The edition is not your edition of the library. It's the edition of Rust that you would like to work with. And 2018 is currently the latest stable release that you can use. And down there, you will find some dependencies. We'll talk about that in a second. The cargo log file, again, Similarity to NPM, package lock JSON. It's maintained by Cargo, so leave it alone. Do not touch it. Do not write to it. Well, you can take a look at it, but never write to it manually. One question that comes up very frequently, should you check in the log file? Well, it depends. If you build an end product, you typically care for consistent builds. You would like to build an end product that really has specific dependency versions baked in, and then you check in the Cargo log file. If you are creating a library, you typically do not check in the Cargo log file because the choosing of the detailed version is done by the end product using your library. If you're not confused, well, take a look at this link. Here you can find all the details in the Cargo frequently asked question lists. I don't have the time to go into further details, but just remember the rule of thumb: end products, check it in; libraries, don't check it in. Then you are typically out of the problem space. With that, let's take a look at my first example. Just to let you know, my examples here are written in a kind of hands-on lab style. I always do that when preparing some talks. So you can take these hands-on labs for your own practice. Just don't take a look at my solution. Just try this hands-on lab and solve it on your own. You can take a look at my solution if you are stuck somewhere. But if you are doing, for instance, in your company, Rust hackathons, or if you are a teacher and you would like to teach some lectures about Rust, or if you are a trainer giving a Rust training, take a look at my hands-on labs. Feel free to copy them, to extend them, do whatever you want with them, okay? But I will now walk you through this example because we are sitting here together. And let me quickly start Visual Studio Code in my samples folder. And here we are. This is the sample, this one, the 01 intro. This is the sample that I would like to show you, okay? The code is very simple, and let's start with the Cargo TOML file here. The important stuff that is going on here is in the dependency section. As you can see it here, I have two dependencies. One is regex, because this sample does something with regex. And the second one is lazy static. Lazy static is an interesting dependency. It allows you to initialize something in a lazy fashion, but statically. So in my case, I would like to compile a regular expression, but only once. And every time I execute the code again, I would like to access the compiled regular expression. And this can, for instance, be done with this package. If I hover over this thumb, I see all the different versions of my dependency. To be honest, this is an extension here. I will not go into the details. You will probably find it on your own. If you just take a look at the extensions in Visual Studio Code here and just type in cargo or crates, then you will find a lot of extensions. In this case, it's a quite handy extension because it shows me all the different versions. And if I do something like this, if I'm using an outdated version, it immediately tells me that I'm out of date and the latest one would be 1.3.9. Okay, now good. Thumbs up again. If we take a quick look at the source code, you see the source code is pretty standard. At the beginning, I'm using a standard IO. This is part of the Rust standard library. You don't need to add an explicit dependency to Rust standard library. It's always available with some exceptions. I know it. It's possible to program without it, but that would be the exception of the rule. Generally speaking, you always have a dependency on the Rust standard library. You don't need to add that to your TOML file. Here we see the two use statements, which refer to the dependencies that we have added in our Cargo TOML file. And this example is pretty simple. In an endless loop, I'm asking the user to enter some text. If the text is quit, we will stop the program. Otherwise, I'm going to call this method down here, is proper date. And here you see, here I'm using the lazy static macro, which allows me to lazily compile for a single time the regular expression. And then I just call the isMatch to tell the user whether he or she has just entered a valid date. Let's try this application. First, I'm going into the folder and I say cargo build. This will build my application. I consciously deleted my target folder. So therefore you see what's going on here. It's fetching stuff from crates.io and it's now building, compiling the dependencies, and it's also compiling my application. Now it's done and I can just cargo run it. And here you see, I can enter something. This is not a date, but if I enter something like this, it says it's a date. So the application is working. We have two dependencies in our cargo toml file, and we have seen how cargo helps us to build the application. In this case, in a debug version, I could now start the Visual Studio Code debugger and set a breakpoint and things like that. This is what cargo in a nutshell does for us. If we take a look here in the target folder, then you will see that we find a lot of interesting stuff here. And here you essentially see where the dependencies are stored, or at least versions of the dependencies are stored. I will not go into the internal details, how this stuff is stored in details. To be honest, I don't absolutely know what's going on behind the scenes, but at least you can see that the dependencies are here in the target folder. Okay. Good. First sample. Let me check if I did everything. Yes. Okay, good. Next one. Workspaces. Workspaces was, they were something new for me as a JavaScript developer, partly as a C# developer. I spent most of my work working with C#, JavaScript, TypeScript, and all this stuff. And workspaces are a really neat thing. What you can do is you can create a collection of more packages in a kind of folder structure. For instance, if we take a look at my samples folder here, this is in fact a workspace. You see, we have on the top level here, we have a separate cargo toml file. You see that one? So if I check the cargo toml file here, we see that we have some members. So my samples workspace consists of multiple, in this case, binaries or even libraries, and they are commonly maintained inside a workspace. And the important thing here is that they share a common output directory. You can see it here, target. So what I can do is I can cargo build all my projects in all my subdirectories which belong to my workspace with a single cargo build. I happen to add a unit test in one of my libraries, so I can also call cargo test. I will tell you more about that in a second, and run the unit tests. Let the system just quickly finish compiling all my code, and you see it will look into all the different projects which are part of the workspace. And in this case, one of my projects here contains a unit test, and luckily it passes. Another important thing is that you have a central cargo toml file, so they share the same dependency resolution, so they share a cargo log file. That means that if you have two different libraries and they refer both to, for instance, something like rand, the crate for random number generation, then both of them will rely on the same version. The system will pick the same detailed version of this dependency for all the libraries inside this one workspace. So this is what workspaces are all about. And here I have added the GitHub link where you can take a look at my samples workspace. That should be enough for getting started. And now we can dive a little bit deeper into dependencies and what you can do with dependencies. And believe me, if you come from the JavaScript world and you have done a lot of package JSON magic, then you will now recognize even more magic, which is going on in Cargo. Cargo knows a lot of very interesting tricks here. As I said, dependencies are called crates. And here you see this is the German Kiste, Holzverschlag, okay? So where can I get my crates from? First and most commonly, you get them by specifying a simple version number. And that means that you get your crates from crates.io. If we take a look, this is crates.io. And here you can look for a specific crate. Let's check, for instance, this one. It's the random number generator. And here you see you get a bunch of description. You can take a look at the detailed documentation. You see the dependencies. You see the repository. The project can specify a homepage and so on and so on. So this is by just specifying a version. I will show you details later on. What if you have some private libraries that you don't want to share publicly? You can set up a custom registry, and all you need for that is just a Git repository. At the end of the day, the cargo tooling, it can get your crates from any arbitrary Git repository that you have inside of your local area network, for instance. So it's super simple to set up a custom registry. There are also offers, third-party offers, for instance, from Cloudsmith, where you can rent some private crates repository space in the cloud if you want. I've added some links here. Again, follow the links and you can read more details. But now comes the interesting part. We can also pick some crates directly from Git. So we can, instead of specifying a version, just specify a Git link. And then the cargo tooling will Git clone the repository, look for a cargo toml file there, compile the whole stuff, and add it as a dependency to your application. So you can have a direct Git dependency using cargo. Same is true for local folders. You can add a path dependency instead of a version number, and then the cargo tooling will look into this path. And it becomes even more interesting. One additional thing that I have for you is you can specify multiple sources. And that becomes very interesting because then you can, for instance, say, cargo, you know what? By default, take this version from crates.io. But if I also have a local version of my library here inside of this path, take this path if I run it locally. That means that I can work on a local version of my library, which is not published to crates.io yet, and I can override the dependency with a local version where I can maybe add some bug fixes or additional functionality. It becomes pretty simple to work with libraries while you are pulling it up, while you are working on this library, and overriding some sources which later come from, when everything is done, from crates.io. That's the idea of passing on multiple sources. I will show you an example later. Now, we also have different dependency types. This is pretty obvious, so I will keep it short. You have dependencies, regular dependencies, you have def dependencies. They are only used for compiling tests, examples, and benchmarks. And then you have build dependencies, which are only used for build scripts. Build scripts are nothing else than Rust programs, which are run by the cargo tooling during building your Rust application. This is what build scripts are. I will not go into the details for build scripts. Please look it up in the documentation. I simply had to skip some things because otherwise my talk would have taken 4 hours. So, simple ones. Referencing crates.io. Here you see some references to crates.io. Random number generators, number of CPUs. I want to find out the number of CPUs, and number formatting. Very, very simple. And here at the end, you have some version selector. And this is what I would like to talk a little bit about, how this works. I already showed you this example. Publishing crates will be an example at the end. Version references, as I told you, are based on Semver. That means the first thing that you can do is very similar to JavaScript and Node.js. You can have so-called caret requirements. Caret is this nice little character here, and it just gives you the latest minor version for the specified major. So in this case, it gives you something between 1.2.3 and 2.0.0 excluding. So 1.x.x, this is what a caret requirement does. The tilde requirements, tilde is the character here, is similar, but it only works here on the minor version. So if you specify 1.2.3, you get something between 1.2.3 and 1.3 excluding. So you get 1.2 star. You can also write some wildcard requirements. I think it's pretty obvious what 1.star does. And you can also add some comparison requirements, something like greater equal 1.2 0. That's possible too if you want to use that, because caret and tilde requirements are too complicated. This is maybe easier to read. But be aware, there are some limitations. If you would like to publish your crate on crates.io, you can't use parts of the comparison requirements and wildcard requirements, if I can remember that correctly. So check that out. Maybe you will get an error with the caret requirements and the tilde requirements. You are on the safe side. Good. Now, what's going on behind the scenes? What is this crates.io? Essentially, crates.io is a big index in GitHub. You see, this is this index in GitHub. So here you see the first 2 letters of all the different crates which are available on crates.io. For this talk, I published one on my own. It's called MTH calc for multi-threaded calculation. So let's look here in MT, and here I find the H underscore, and here it is. This is the example that I published for this talk, I think somewhere last week, and here you see the different versions of this MTH and so on. This is the index of all the crates. Okay, so and if you want to build your own custom crates repository, then you have to set up something similar. But of course, checking all this stuff inside of Git repositories is not very convenient. Therefore, a fully blown crates repository like crates.io offers a RESTful web API with which you can look for crates and find also their download locations. So there are just tarballs at the end of the day. So if you take a look at this one, for instance, this is a very simple give me all crates query that I sent here. And you see all the different crates with some download links and so on and some meta information. You can also pass in some queries. For instance, I've done that here. You can see, go up here. Again, I'm looking for the sample crate that I created for this talk. And the second one happens to be exactly my example crate that I published 2 days ago. And you see, yeah, it's just a demonstrating cargo, and it was published by me. And you see that here. So this is what crates.io is behind the scenes. It's a web API on top of a package index stored in GitHub and a bunch of tarballs sitting somewhere on the internet. In the cargo documentation, you can find details about how to replicate the whole package repository. If you want to have a copy in your own local area network or things like that, please consult the documentation if you would like to do something like that. With that, let's again take a look in another example. We will focus on the cargo stuff, but it hopefully contains some interesting stuff for you too. So what I did here is I made a mistake consciously. You see here, I was specifying a tilde requirements, which tells the system essentially, give me something 1.0 anything. And now my tooling tells me, hey, Rainer, there is already a 1.13. So what I can do, for instance, I can do something like this. Change that to a caret requirement. And what did I tell you? This will now give me the latest 1.x dependency. So now my tooling tells me everything is fine. You will get the 1.13 version of this library. Sounds good. Let's take that one. In that case, I'm having here a random number generator. I'm asking for the number of CPUs and I'm doing some number format. Essentially, what I did for this sample, it's very similar. I calculated pi. I like to do that. I like to calculate pi, but in a very special way. I'm doing a Monte Carlo simulation to calculate pi. If you're not familiar with Monte Carlo simulation is very simple. If I ask you, what is the probability to get a 3 if you're rolling a dice, you will probably say 3/6, right? Of course. But if I give you a real physical dice and you are not sure whether it was manipulated, and I ask you the same question again, then the only thing you can do is let it roll a lot of times, count the results, and apply a little bit of statistics. And this is what this example does. It takes a normal circle and a unit circle with the radius 1, takes a lot of random points and calculates the ratio of points within the unit circle and outside of the unit circle. And this ratio multiplied by 4, if you only take a quarter of the circle, is pi. This is Monte Carlo. And of course, this is a problem where you can do a lot of multi-threading. So I thought it would be interesting for you to see how we can, for instance, use the multi-threading stuff here. Here I'm spawning some threads. But the important thing for my talk here is that we are here accessing the libraries where I edit the references in my cargo toml. Here you can see I'm referencing the random number generator, here the number format, and here the number of CPUs. And what I do essentially here is I'm spawning as many threads as I have CPUs, and I'm generating a lot of points. And at the end of the day, I should get something in the ballpark of pi. So this is what this stuff really does. Want to see it working? Well, I hope it will work. Let's see. Let's go into this folder here. Let's do a clear and say cargo build. This one, pretty fast. Why was it fast? Can you remember what I did a few minutes ago? I compiled the entire workspace. Cargo is smart when it comes to incremental building. It recognized that nothing has changed, so it is super fast, and we can immediately cargo run the whole thing. And it's now running for a bunch of seconds. And at the end of the day, woohoo, I get 3.1418. It's not pi yet because I only did 7 million or 8 million calculations per second. But still, it gives me something near pi. But I want to show you the same example with cargo build release. I heard Ryan talking about the difference between debug and release version, and I would like to demonstrate that here with this performance-oriented example. Let's release build it. Of course, it has to rebuild all my dependencies, now optimized for performance. And now we can cargo run it again. Cargo run. And in this case, oh, sorry, of course not like this. This is much better. Do you see the difference? Now this is the difference, right? 1 billion calculations per second compared to 8 million calculations per second. So this is what Ryan meant when he said, don't forget to compile your stuff in release mode, because there is a huge difference between Rust and Cargo building for debug versions and Rust and Cargo building for release versions. This is what I wanted to show you here, just to highlight some Cargo features. Now we have the dependencies and we have the release builds. This was this example. Now let's take a look at something which is less obvious. This is now a path dependency. What if I take my feature that I can run a certain mathematic algorithm in parallel on all my CPU cores and put them into a separate library? And this is what I did here. I took out one function of my application and I have put it into a separate crate, in a separate, no, not a crate, in a separate package, which is a subdirectory of my cargo toml, which is the binary that I would like to be able to run. Here you see it has its own source directory. It has its own cargo toml file, and here you see the implementation of my library. And here I am referencing exactly this path. So I'm getting the library from a subdirectory. Let's take a look at this example in real life. Here it is. Here you see I have my cargo toml with the path here. And if I zoom in a little bit, then you will see that this path points up to here. If I open this one, here I have the implementation. And here you see the dependency of my library. It needs the number of CPUs. This is no longer a dependency of my binary, which calls my library, because the binary is not interested in the number of CPUs. That's an implementation detail of my library. If we take a look at the source code, this is what I did. And please note, this is what Ryan already mentioned. This is how you add unit tests to your libraries. I'm now not talking about integration tests. I'm talking about unit tests. So in this case, I refactored out a helper method run on all CPUs. I will not go into the details of the implementation. All it does is it gets the number of CPUs on my system. It spawns the exactly same number of threads. I know this is not perfectly optimized, but I think you get the point. And at the end, it aggregates the results by iterating over the results of the thread and returns the result in the number of CPUs. That's all it does. And here at the end, I have a unit test for that. So let's play a little bit with this example here. So I have to close it here. Okay, so let's go into my folder here and let's cargo run the application just to make sure that it still works. It calculates pi slowly because it's debug, but it calculates something near pi. If I say cargo test, and that's the next tool that I wanted to show you, this one, it runs no unit test because I'm now not in the workspace folder, I'm in the binary folder. But if I go into the library folder here and run cargo test again, everything is fine. My unit test was run. And this really works. Let me quickly do something is lower than one or lower than the something like this. Let me see if I can screw it up. No, it doesn't make sense. Okay, I will not do ad hoc changes to you can try it on your own. It really executes the test. It really works fine. So what you have learned here is these path dependencies. They are really convenient when you split up larger applications into libraries. And now I think you get the idea. By combining the version number with the path, you can easily override a dependency while you are developing the library locally. Okay, so yeah, I already showed you this example. This is how a Git dependency looks like. And it happens to, I happen to have this example here. This is exactly the same application that you saw before, but now I have my small little library. I pushed it onto GitHub. So it's available here. You can take a look at it. It's exactly the code that I've shown you. And now I'm having a Git dependency in my application. I no longer have this subfolder here on the same level. I'm having a Git dependency. Let me show you how this works. Let's go into this folder here. And if I say cargo build, it will build everything. And yeah, if we delete the target folder again, let me quickly do that. Let me see if I have a target folder here and run it again. Exactly. And let's wait for another few moments. Yeah, everything is compiling. And once it's done, yes, I can show you this one. See? It automatically pulled, in this case, the latest commit of my implementation from GitHub and compiled it on my machine on the fly. This is what we have here in this Git dependency. This is pretty neat. I liked it when I discovered that, looking into the details of Cargo. Yeah, I already showed you that one. There are some advanced topics which I cannot cover because in the last, let's say 15 minutes or so, or 10 minutes, I want to show you something completely different. These advanced topics, you will probably not need them when you get started with Rust, but over time you will need them. So I would like to tell you how this works. This feature, I already mentioned it multiple times. So this is how you would write it in your TOML file. You specify a version number. This version will be taken if you publish your library as a crate to crates.io, but you can have a local version of the dependency in a certain folder and therefore have some additional debugging capabilities and things like that. The next one is overrides. Overrides are even more advanced as this specifying multiple locations in this area. If you want to know all the details about overriding, if you want to go all in into library development and you have to develop patches for your libraries, definitely check out overrides. I added the documentation link here. Please excuse that I will not go into details here because of time limitations. Finally, you can also have platform-specific dependencies. So in this case, if your target and if you build the target with the configuration Windows, you might have different dependencies than if you target, for instance, Linux or something like this. Features are interesting. Your dependencies can have optional parts, which are called features. And if you have a dependency on a library which offer features, then you can add, opt in, or opt out from these features. And depending on that, the package behaves differently. Maybe you have a certain package which can optionally offer some features to convert something to PDF, but you can opt in or opt out of this feature. Maybe you don't need PDF support in your binary, then you can opt out from this feature. This is what optional dependencies and features are all about. And finally, build scripts. Build scripts are great. They are essentially a Rust application, a specific file, build.rs, which is in the root of your package folder. And this build.rs file is compiled and executed before Cargo is building the package. So you can do a lot of crazy stuff in this build.rs file. You can, for instance, build some C dependencies, C libraries. You can generate code on the fly. You can in code, find out some platform-specific configuration settings and change them before you apply these settings when you compile your package. So this is what build.rs is all about. Please check out the docs if this sounds interesting for you. I will turn on the lights so you can see me a little bit better. Good. We have, I think, something like 10 minutes left, and I would like to go into my last big topic here for the last 10 minutes, and that is publishing crates. What if you create a library and you would like to share it with your peers, you would like to share it with the world? What do you have to do? First, you need to learn some new cargo commands: cargo login, cargo package, and cargo publish. Not that much. Of course, with cargo login, you can authenticate against crates.io. With cargo package, you can build your library into a tarball, and with cargo publish, you upload everything to the registry. Now, what do you have to do if you would like to publish a crate into crates.io or your custom crates repository? First, get an API token from crates.io. Yeah, I think that's simple. Then add some meaningful metadata. Add a README file, things like that. Add your name, a description, and I think you get the idea. Finally, if you want to be a good citizen, add some unit tests. Maybe optionally, add some integration tests. Add some benchmarks. Add some example code, something like this. Depending on the necessities of your libraries, you have to invest more or less time in these areas. At least you should add a bunch of unit tests. Document your API, including examples. And I will show you more about that in a second when we go into my last hands-on lab. And finally, you use Cargo to publish everything. The first step, you can see it here, is you run a dry run version of Cargo publish. Dry run means that it does everything except really publishing it. So you can check your package, your setup for potential failures. You can check the content of your package by doing cargo package -- list. It will show you what's in your package. Of course, we want our package to be small, and therefore we want to check out whether really only the necessary things are inside of our package. Maybe we have added some larger, let's say, text or HTML files which shouldn't be part of packaging. Then we will recognize a mistake like that. And finally, you upload everything using Cargo Publish. This is the workflow that you have to follow. With that, let's spend a few more minutes in another example that I have prepared for you. Let's open Visual Studio Code with this version of my great mathematic multi-threaded calculation library. I know it doesn't make so much sense, but I thought it would be a good idea to have it here. So this is now a crate that I would like to publish on crates.io. I already have published it, so I can show it to you in a second. This is what the TOML file looks like. Obviously, I added a bunch of more metadata. I don't think that I have to describe all the things here. You can take a look at my GitHub repository or read the docs. These are my dependencies. I don't have to talk a lot about that. In this case, I get a warning that I already would have a 1.13, but it happens that I'm fine with that. But now comes the interesting stuff. In my example code, I will show you that in a second, I have an example that describes how to use my library. And this example is using a random number generator. in that case, I'm not adding a dependency, but I'm adding a def dependency, because this is something that my final version of the crate does not depend on. It's only the examples. You might ask yourself, hey, Rainer, examples? Aren't examples just documentation? And that's a big wow. That was a big wow effect for me as somebody who was new to these features of Cargo. Example code is executable documentation. So let's go into that one, because I think it's really, really great. If we take a look at the library, then you will see that I have some example code here inside of my structured documentation of my function. And believe it or not, I can run these examples. I can build these examples. I can even add, here you can see that one, hidden code, which contains unit testing code, which will not be part of the documentation, but it helps me to verify that all my documentation examples still work. Let me show you that. Let me show you how this looks like. I can do the following. I can say cargo test --doc, and that is now running my embedded code here in my documentation area. So for instance, let's say if it's smaller than 1, something like this, doesn't make much sense. Let's run it. And it crashes. Yes, it crashes. I now ran parts of my documentation using the Cargo toolset. And the same is true for building this stuff and all these things. So this is really nice. And if again, now you understand what I meant with def dependency, because this dependency is only used inside of my documentation. You see it here. This is part of my documentation code. Now, what else can we do with this stuff? If we have nice documentation, we can run cargo doc. If we run the cargo doc, then we get, let me quickly open this one here in Explorer. If I go into target and here into doc, I will now see here an index.html, and I will get a nice little human readable documentation about my crate. If I go here, you will see the documentation from my Rust file. And here you can see this nice little example. This is exactly the example that I showed you a few minutes ago inside of my Rust code. Okay. So cargo doc is a built-in API documentation engine, which comes in really nicely if you are building reusable libraries, because we all know that a library is only as valuable as its documentation, because if you have no documentation or poor documentation, how should people find out how your library works? And I think this is really nice. Well, obviously, you can also add some unit tests to your library, just as we had before. I will not go into the details here. So if we now run cargo publish dry run, this one, yep, everything is good. It builds it. Yes, and fine, you see, no mistakes. If I would have some mistakes, for instance, if I would have forgotten some mandatory metadata in my package section here, I would have gotten an error. And if I leave out the dry run, it really publishes everything on crates.io. And this is what I already did. So if I go to crates.io and I'm looking for multi-threaded calculation, this is the example that I created for you. Then you will see this is now the content of my README file. Here you have all my meta information that I added to the cargo toml file. I can go to the documentation, and that leads me to docs.rs with the name of my crate. And I didn't have to do anything for that. It was done automatically just by uploading my crate to crates.io. It automatically generates the documentation for me and publishes here on docs.rs. And here, just to prove the point, you see the public documentation of my sample calculation here. So this is the result of me publishing my crate from a different GitHub repository. Okay, so here you see the README file with the documentation and so on. I hope this one was interesting, so you get a better idea of what it takes to publish something on crates.io. And I was able to show you a bunch of, well, not so obvious stuff that Cargo is capable of doing, like, for instance, running tests, running the example code, even executing unit tests inside of the example code. If you're interested into more details, please take a look in my GitHub repository and in my slides and the hands-on labs. So we are already at the end of my talk, and let me quickly do a summary before we open it up for Q&A. First, Cargo is an indispensable tool for Rust development. Cargo is your friend. You will use it every single day. If you come from a world of JavaScript and TypeScript like I do, probably the basic features of Cargo will not be difficult for you, because you will find many similarities with the Node package manager. For me, as somebody who was new to Rust a few months ago, I detected some unexpected features, like, for instance, the nice integration of the documentation engine and things like that, which I wasn't expecting from a tool like that, but now I really find them very, very interesting, and I would love to have things like that in other programming languages that I use too. There is some room for improvement. However, my most important point of criticism here is that it's rather hard to set up a custom package repository. I work a lot with enterprise customer. This is my daily business. I earn money by helping companies building great software. And many of these companies, they have some intellectual property which they don't want to share with anybody. It could be easier with Cargo to set up a custom package repository. If I compare that with what I'm used to from C# and JavaScript, there all of the major Git servers, for instance, they come up with some out-of-the-box support for a Node package management repository, for a NuGet repository, and so on. You have a lot of great cloud services where you just, with a click of a button, you create a private repository, and this is unfortunately not that widespread in the area of Cargo and Rust. So you have to do a little bit of tweaking, hand tweaking here, or maybe select one or two offerings which are not that well documented yet. So this is room for improvement, but I hope that as Rust gets more wider used, we will find these improvements here. With that, I hope that you enjoyed the last, I don't know, 3/4 of an hour, something like this. You learned something new. You got my material, and we can open it up for questions if there are some. Stefan, did you take a look at the Discord server? Do you have any
constantly.
questions?
The Discord server is again flooding over with lots of interactions from the community. So I'm actually enjoying that a lot. So people are writing, people are discussing during your talk. There were a lot of things people have seen for the first time, even if they're long-term Rust Cargo users. Especially the doc feature was very new to a couple. There was one question from Sayan. I hope I pronounced your name right. If you go to your first example on line 38, so very specific line. Yeah, so there is static ref RE colon. And Sayan wants to know if you can explain a bit on how the RE defined in sort of scope is available outside. So
it's a static variable. It's a static variable which is available throughout the entire lifetime of the application. So what essentially lazy static is doing, when you enter this code for the first time, it initializes this static variable. And when you enter this code for the second time, it will not reinitialize everything again. So therefore, if I reference this RE variable here, it's just a variable, I get the compiled regular expression which I got when I called isProperDate for the first time.
All right.
I hope I described that good. And just Google for static refs, and you will find more detailed information about that.
As far as I can read it from the chat, it was also Sayan's first guess. in
Okay.
that. And I think you answered it correctly.
Okay.
Other than that, there were a couple of questions, but the community answered it on the go in the chat, which is very cool.
Love that.
I guess you have a couple of things to look up. And with that, yeah, so Sex, thanks for the explanation. Smiley face. So I guess we are good there. If you have any more questions, Rainer will be in our Discord, of course. So are lots of other people. So I'm amazed how many people are online right now in the server on YouTube and are still with us on Zoom. I think this was a tremendous first meetup. I enjoyed it a lot. I learned a lot of new things. So we aimed this meetup specifically for newcomers and for first timers. To learn together, to see together how this programming language could change the way we develop software and the software we develop. And with that, Rainer, do you have any last words before we?
No, I'm super happy. When we sat down, remember when we sat down a few weeks ago and we said, hey, let's kick off a Rust meetup in Linz. We weren't sure whether we would have a beer, the 5 of us or something like this, and talk about Rust. And now we have dozens of people actively engaging, and I'm super happy. And thank you everybody for coming. And I'm already now looking forward to the next Rust meetup, which will happen in approximately 1 month.
Exactly. So with that, I want to thank you, Rainer, for giving your talk, Ryan, for giving your talk, for being with us, the Linz community for being with us, the international community for being with us. There's so many people from outside Linz, Upper Austria, from all around the world joining us for today. This has been amazing. I'm really looking forward to the next one. And yeah, see you around. Happy rusting, happy coding. And see you next time. Bye-bye.
See you next time. Bye.
I end the live stream.